we are presenting here our prototype to address bias and stereotypes in language technologies from a Latin American perspective. We are very happy with the outcome of this project so far. We have been working for quite some time with a growing team, an interdisciplinary team with social scientists, computer scientists, communicators, and we have learned a lot in the process, and we feel that other people have been learning a lot as well. We have received very encouraging feedback from the participants in the workshops that we have carried out, and we have learned a lot from their interaction with this tool. And we have integrated these learnings in the tool as well. So to begin with, we need to define a little bit what we understand by bias. Yeah, bias is an inclination or a prejudice against one person or group in a way that is considered unfair. And and this is mostly based in stereotypes. Yeah, when we have a stereotype that a person belongs to a certain group and this group has a characteristic, we can act with bias, that is with unfair behavior. So we want to, we know that many language technologies encode biases that then can act as discrimination in the working of these technologies. Let's see some examples in Spanish. The example that I'm giving now is poor people are, but this does not work in English. In English, there is a shallow patch that Google has implemented, so that when you type in English poor people are, there's no autocomplete. But if you type it in Spanish, there's no shallow patch preventing the underlying technologies for Google search to let you know what bias these technologies have related to poor people. And you can see things like poor people are responsible of their own poverty. Poor people are poor because they choose to be, and then some other things like here, the poor are the best business in the world. The poor are happier, things like that. So if this is not censored by superficial rules, these things come up. Yeah, another example, when you translate from a gender-neutral language like English to a gendered language like Spanish, you can see that some professions tend to be translated as belonging to a given, associated to a given gender, like not when the context is very small, like for programmer, it can be translated as programmer feminine or programmer masculine, but when the context is bigger and a bigger combination of genders should be displayed to account for masculine for programmer, masculine for babysitter, then you have this. Programmer is always masculine, babysitter is always feminine. You don't have it randomized. You don't have a programmer as feminine just the same amount of times as programmer masculine. So there is a bias in the underlying technology that powers these translation engines, that programmers are men and babysitters are women. Yeah, and this is something that we want to know. And there are currently technologies developed in academia and in industrial contexts that allow to audit these underlying technologies, but these tools that have been developed in academia have a very high technical requirements. So you need to know a lot about mathematics and statistics and programming to use these tools. But what it happens is that the people who know a lot about stereotypes and discrimination are not necessarily people who can actually program and who have the skills to use those tools. So what we did was develop a tool that allows people with discrimination and stereotype expertise to actually audit and inspect and explore these underlying technologies and to characterize the biases that are found there, so that strategies to mitigate or address these biases can be taken that are not so superficial as simply censoring a word that is considered bad. Yeah, and also we wanted these technologies to be developed, to be accessible for everyone, because some of these technologies are available for English, and many studies have been carried out for English, but there are fundamental differences between English and other languages, as could be expected. When you have a characterization of bias in English that has this aspect in the graphic in the left, and you translate this, which is what computer science typically do. They say, okay, this works for English, let's translate it and do the same for Spanish. The results for Spanish are totally different. So you cannot simply port from one language, from one culture to another and expect the same things to apply. So we really need local experts to be involved in characterizing bias for these technologies, because a general characterization does not work for all. Okay, so yeah, it is necessary to audit the bias and stereotypes in more language models, not only in English. And we have been seeing lately how biases can be widespread and have very, very strong impacts, as in ChatGPT, technology that was recently disponibilized for everyone. Here you can see you can see how ChatGPT can be asked to write a program for whether a person should be tortured based on their country of origin, and effectively ChatGPT has not any problem to provide a program that actually says that if the person is from North Korea or Syria or Iran or Sudan, then the person should be tortured. If not, this person should not be tortured. Yeah, so this has probably been censored now. This is an example that was obtained from ChatGPT some time ago, but these kind of biases are found in technologies that people are using anywhere, and they can affect strongly people in ways that are not foreseeable. Yeah. So here we have another example. We have developed a prototype that is also available at Huggingface with a graphical interface and without resorting to technical complexities. So we have done a very big effort together with participants in interdisciplinary teams in our workshops to make these auditing tools accessible to a wide range of people without resorting to unnecessary complexities. And we find that people can actually use this prototype successfully. First of all, we have provided tools to see intuitively bias in a word embedding. This is an example that was actually found by participants in one of our workshops. These were nutritionists working with the representation of dietary choices in social media, and they saw that the words for fat masculine and fat feminine were distant, and the words for ugly masculine and ugly feminine were also distant between each other, but ugly feminine and fat feminine were almost the same in this dimension, in the vertical dimension. They differ in the horizontal dimension, but in some respects, they are almost equivalent. Yeah, this is something that can be seen with our tool, and what this is telling us is that the underlying technology that we are auditing considers ugly feminine and ugly and fat feminine almost equivalent in some senses, that it does not consider ugly masculine and ugly and fat masculine. This impacts the behavior of applications that are based on this underlying technology. For example, the autocomplete for fat masculine says the fat bondiola. Bondiola is a kind of meat here. The fat in Alice in Wonderland, the fat have suffer less the cold, they sing better. Yeah, these are mostly positive things for fat masculine, but when you want an autocomplete for fat feminine, you have the first autocomplete is the same, yeah, bondiola, which is this meat, but then you find they are nasty or they are disgusting. Yeah, the fat feminine are disgusting. The fat feminine can get pregnant. These are mostly negative completions that are not associated to the masculine, counterpart of fat. So this is very, very useful to take action in the deployment of these technologies. Yeah, to take deep action, maybe to train these technologies in a different way, to restrict the kind of uses that they can actually be deployed into. But this evidence is a little bit non-systematizable. Like, okay, here I have had to explain to you what this means. So we need a way to systematize this, and the way of systematizing this that we have found quite satisfactory is to characterize different meanings of that we are interested in exploring. For example, here we have a feminine meaning to the right and a masculine meaning to the left, and then position different words with respect to these meanings. And we find things like knitting and sewing and dancing are more feminine than, for example, argumenting, reasoning, thinking, which are clearly more masculine. Yeah, this allows us to have a more systematic assessment of bias with respect to a given sense or given meanings. Yeah, we can do this also with professions, and we can see here that feminine nurses are much more feminine than masculine nurses are masculine. This also is quite translatable into needs for action. Yeah, the limitation of this systematization is that, for example, it cannot properly deal with ambiguity, it cannot properly deal with multi-word expressions, it cannot properly deal with non-binary semantics. These are all things that we found in interaction with users who wanted to represent their experience of discrimination. And this is why we incorporated in our tool something that allows us to work with ambiguous multi-word expressions that are non-binary meaning, and that allow us to work with language models. Yeah, that language models are these tools that generate language, like ChatGPT, that can have a conversation with you, but that can also suggest how you want to complete the text, or that can generate a text for you. Here we can see how a language model complete something that I started, like the stereotypes are based on age, for example, ageism, yeah, which is a word that apparently this language model did not know, is completed with something that questions the capacity of old people to understand information, which is at least deploying some stereotype. Yeah. So what we implemented was something that had been proposed also in academic in an academic origin. Yeah. And what we do is we ask a language model like ChatGPT to tell us how probable it is that this language model could generate a sentence like, the Bolivians cannot manage their money, the Argentines cannot manage their money, or the German cannot manage their money. And this language model told us, well, it is this probable that I generate the Bolivians cannot manage their money, but it is only this probable that the German cannot manage their money. This is clearly biased behavior, because if it were non-biased, the probability of generating one or another sentence would be equal. It is not equal. It is more probable that Bolivians are associated with not properly managing their money or not managing their money than Germans. And this may have implications in, for example, granting credits to people. So incorporating this tool to rank sentences according to the probability that the language model generates discriminatory behavior, actually, has allowed us to deal with multi-word expressions. We have here the Bolivians, but we could have people from native people, so multi-word expressions. The context allows us to distinguish different senses, not mixing them, and dealing with ambiguity. Yeah? And also this allows us to work with senses that are not necessarily binary, because here we're working with 3 options. We could work with 10 if necessary. And we could assess the discriminatory behavior, the possibly discriminatory behavior of this language model. But now we are very happy with this tool, but now we need that this tool is actually used, that people who know about discrimination actually begin characterizing biases, because we computer science people only know 2 biases, gender and race biases, as they have been studied in the North, which is a totally different way of the way we experience, for example, race here. Race in Argentina is something that is perceived totally differently than in the States. So we need more biases, more stereotypes to be studied. And this is what we are now hoping for, that people go use this prototype and begin characterizing biases and assessing them in language models that are available or that are being used in institutions, in academia, in industry. Our tool is not only available as a graphical interface via Huggingface, it is also available as code in GitHub, as with the Docker instance, so that it is more easily deployed in any environment. We have an extensive documentation, and we also have video tutorials so that it can be used, people can begin using it without having attended any workshop. So we are really, really hoping that many people will begin characterizing the stereotypes, the biases, and the discriminations that these tools are currently inflicting upon all of us.